Hey, what's up guys? Today we're going to learn how to solve for missing angle measures in right triangles using inverse sine. Alright, here it is. Okay, so I'm going to assume that you're pretty comfortable using the sine ratio to find missing side lengths in right triangles, but it turns out we can use something called inverse trigonometry to find missing angle measures when we know the side lengths already. And so in this particular case, if we're trying to find this angle theta here, but I'm given a couple of side lengths, then I can calculate that angle using something called inverse sine, or it's also known as the arcsine. And so I'm going to set this up the same way as I usually would. So I have an angle here. Well, I don't know the angle, but if this is the angle I'm interested in, and I'm given the opposite side as well as the hypotenuse, then I can set this up how I normally would for sine. So I can write the sine of theta equals the opposite side, which is 7.5 in this case, divided by the hypotenuse, which is 9.5. Okay. And I could type this into a calculator right now, but there's no need. I can always take care of that at the end, so I'll just leave that there for now. And now you need to think, well, I need to solve for theta. I want to know what theta is, and so I need to get the variable theta by itself in this equation. And it turns out the way you do that is you take the inverse sine of the sine of theta, and you can think of that as canceling out sine. So what I'm going to do here is, and whatever you do to one side, you have to do the other side. So I'm going to take the inverse sine of both sides here. And it's very important to note that this -1 here isn't actually a -1. It's not an exponent of -1 or anything like that. It's just notation to represent the inverse sine. So I'm going to take the inverse sine of the sine of theta. And then I'm going to also take the inverse sine of the right side here. Alright, and now you can think of the inverse sine here as undoing the sine, which is going to unlock the theta here. And then now that we have theta isolated all by itself, this here is what you're going to want to type into your calculator. And basically what that does is you're asking your calculator, if I have an opposite over hypotenuse ratio of 7.5 divided by 9.5, then what must my angle be in the right triangle? That's basically what you're asking your calculator to calculate for you. And it turns out that that is about 52.14 degrees. Alright, and then it's worth mentioning, you might have noticed that, well, really all you had to do was this. All you had to do was find your ratio, 7.5 divided by 9.5, take the inverse sine, and then jam that into your calculator. And so a lot of this looks like unnecessary steps, and from a certain perspective that's true. But in my opinion, it's very worthy of your time to develop these writing conventions, because not only are you learning how to use trig and use inverse trig, but by doing this, you're developing an understanding of how to solve basic trigonometric equations. You're learning that in order to get a variable out from within a trig function like sine or cosine or tangent, you can take the inverse sine, the inverse cosine, the inverse tangent, in order to unlock that variable. Okay. And now we'll do another one here. So here we're asked to find this angle theta, and again we know a couple of sides, and the sides we know are the opposite side and the hypotenuse, which makes the inverse sine what we're going to end up using here. So I'll set it up just the same way. The sine of this angle is going to equal the opposite side, which is 4.3, divided by 9.8, which is the hypotenuse. And again, I'm trying to solve for theta here, so I need to get it out from this sine that's surrounding it. So in order to do that, I'm going to take the inverse sine of both sides. Okay, so I'm going to take the inverse sine of the sine of theta, and then I'm also going to take the inverse sine of the ratio on the right side. Okay, and you can think of the inverse sine and the sine canceling, quote unquote. And so that'll leave me with theta equaling the inverse sine of 4.3 divided by 9.8. Okay, now this is what you want to type into your calculator, and that will give you roughly 26.03 degrees. Alright, and with that said, guys, it's been demonstrated.